10.3, area of regular polygons. The area of a regular polygon is related to the distance from the center to a side. You can circumscribe a circle about any regular polygon. The center of a regular polygon is the center of the inscribed circle. The radius of a regular polygon is the distance from the center to a vertex. The apothem is the perpendicular distance from the center to the side. So below, a portion of a regular octagon is shown that has a radii and an apothem drawn. What is the measure of each numbered angle? Explain how you found these. So in this case, it's an octagon. So with an octagon, there are 8 triangles meeting at the center to make up your angle. So in this case, angle 1 is created by the intersection of 8 triangles in the center there. So to find the measure of angle 1, we would just take 360 divided by 8. 360 divided by 8 is going to give us an angle measure of 45. So angle 1 is just 45. Then, like in the last example, to find the measure of angle 2, it's half of that very same angle measure. So we're going to take the measure of angle 1 and we're going to cut it in half. And so half of 45 is 22.5 degrees. And then last but not least, we've got our 22.5 degrees. We've got our right angle, and we're looking for angle 3. So to find angle 3, we're going to take 180 minus the 2 angles we know. So that's 90 and 22.5. So that means the measure of angle 3 is equal to 67.5. And so now that we know the angle measures, if we wanted to, we could start finding side lengths if they gave us some side lengths to work with. Area of a regular polygon. So the area of a regular polygon is half the product of the apothem and the perimeter. So we're going to take the perimeter of the shape, times it by the apothem, and then divide by 2. So you want to make sure you star this for your notes so you have it easy access to find the area of all your shapes. So what is the area of a regular heptagon? Well, remember, heptagon means 7 sides, with side lengths of 6 and apothem of 4.2. So the first thing we want to do is find the perimeter. So we're going to take the number of sides times the side length, which is 6. So 7 times 6 gives us a perimeter of 42. We already know our apothem, which is, in this case, 4.2. And so all we have to do to find the area is plug these into the formula. So area equals 1/2 your apothem, which is 4.2, times your perimeter, which is 42. And so if we were to put that in our calculator, multiply it out, we should get that our area for this heptagon is 88.2 centimeters squared. So make sure you're finding your perimeter. They tell you it's a regular decagon. So a decagon is 10 sides. Worst case scenario, you could have counted, but knowing the number of sides is also very helpful. So for perimeter, we've got the number of sides times the side length, which is 8. So our perimeter is just 80. The apothem was given to us, which is 12.3. So to find our area formula, or our area, 1/2 apothem times perimeter. So 1/2 12.3 times 80 gives us an area of 492 inches squared. So example 4, what is the area of the hexagon at the right? Well, if we look at the diagram, we are clearly missing our apothem, so we have to find that. And in order to find our apothem, we have to use trig or special right triangles, but we didn't teach you special right triangles, we taught you just basic trig first, so we're going to use just trig. Alright, so what we're going to do is we're going to focus on just one of these right triangles. And so I'm going to actually sketch it over here to make it a little easier. All right, so that's my right triangle. I have my angle. I know that this angle here is 30. I suppose I can make that bigger, so let's erase that real fast. All right, so we've got, still have opposite and adjacent, which is our tangent ratio. So the tangent of 30 over 1 equals opposite over adjacent. So with trig, we cross multiply, and in this case we get a times the tangent of 30 equals 1.5. How do we move the tangent of 30? Well, if it's multiplication, we divide. And so we're dividing both sides by the tangent of 30. And when we plug this into our calculator, assuming our calculator is in degree mode, we should get that our apothem is right around 2.6. So now that we know what our apothem length is, we can find the rest of our measurements needed to find our area. We know the side length is 3. We know there are 6 of them. So finding our perimeter is easy. It's 6 times 3, which is 18. And now we have everything we need to find the area of this hexagon. So area equals 1/2 your apothem, 2.6, times 18. We're going to plug that in our calculator and see what we come up with. So for this one, we'll sketch the triangle to make it a little easier to see what we're trying to find. So if our side lengths are all 16, that means this half of the base of the triangle is just 8. We're looking for our apothem. And because it's a hexagon, we know that this angle up here should be 30. Okay. And so now we are going to use trig to find the apothem. So we've got opposite. We've got adjacent. Opposite and adjacent is tangent again. It's not always going to be tangent, but a lot of times it will be. Tangent of 30 equals opposite over adjacent. So we're going to cross multiply, and then we will have to divide because our variable's in the bottom. So cross multiplying gives us a times the tangent of 30 equals 8. Then we divide by the tangent of 30, and we get that our apothem is 13.86. All right, and so that's part of the problem. So we've got that out of the way. So the only other thing we need to find is our perimeter. Well, we know it's a hexagon, which means it has 6 sides, and every side is 16 feet. So 6 times 16 gives us a perimeter of 96. So if that's the case, we are going to take our area formula, 1/2 times your apothem times your perimeter. And so when you multiply that all out, you get the area of your regular polygon, or regular hexagon in this case, to be a whopping 665.28 feet squared. Nancy has a gazebo shaped like a regular octagon. Each side is 8 feet long. If the gazebo has an area of 222 feet squared, what is the length of the apothem? So we're going to set up the area formula for regular polygon and work backwards. Area equals 1/2 apothem times perimeter. So we know our perimeter, because perimeter is 8 times 8, which gives us 64. And we're looking for the apothem, so we plug in what we have. 222 equals 1/2 apothem times 64. Cut your 64 in half because we can just apply this directly. So you've got 32 times the apothem equals 222. We'll divide by 32 to remove it from the apothem, and you get your apothem to equal 6.94. And you're done.